Good morning, everyone. In this video, I will try to give you a summary about this coming week because a couple of important things happening at the same time. So I thought that particularly for test one preparation, I would like to share some of the practice questions that you really need to focus on the lab manual practice problems and other things. So this is my student view on the screen that you're seeing. When you go to lessons and modules, we're in module 2. Back in the day, when we finished module 1, that's when test 1 was happening. Here, we already finished module 1 last week as of Wednesday, I guess, right? Like 4th of September, we've done everything what we needed to do in week 1, week 2, week 3. All the materials covered in there is good to go for test 1. However, we started module 2, which is week 4, and as you open module 2, you will see that red bold writing. Please take care about that because you will also be learning a new concept called difference of quotient, but it's not going to be included in test 1. So we don't freeze learning just because we're having a test, but this week is an important week also for the test 1 and web assigned quizzes and so on. So when you go to week 4, right, so this is my, again, student view. On the table of contents, your first folder is test 1 preparation folder. So first I want to talk about this test 1 preparation. So click on the second item on that folder, looking module 1 learning objectives. Please read those objectives. I know it's not very entertaining and joy, but that will give you a summary about the things that you learned in the past 3 weeks, and are you confident with them? Are you familiar at least with them? What are some of the things that you're having a difficulty that you need to emphasize and work on it a little bit more? I mean, don't spend like an hour or so, but just 5 to 10 minutes. Give it a thought. That's what it's important. So then the next item on there is lab manual problems, and there are 2 PDF forms. One of them is the key for the lab manual. The other one is the actual problem. So what I'm going to do, this is the vital part of this video, I'm going to skim through those lab manual module 1 practice problems and try to give you some suggestions. First question, and it starts, you have the lab manual full form as a digital format also. It starts with page 48. You see some function graphs, and from those function graphs, we want you to identify the names. Here in the lab manual, we're providing you the names, but in the exam, we might not. So what I'm saying is this portion, the names of the functions, is not going to be provided to you, but we might give you some of the graphs from here and ask you identify what's that function called. For instance, what is this function called? Is it an exponential function? Or is it a rational function? What would you call it? What is this function called? What is this one called? Right? So the names are not going to be provided to you, but you will be given graphs, parent function graphs, and you will be asked to identify their names. So that's one. The second one is a typical good test 1 question. You're plugging an input, finding the function value. A function value is given by part E, and we're asking for the what would be that input. We're asking the domain and range of the function, and if the function is 1-to-1, how would you identify that, if it is 1-to-1 or not? So this is like your discussion post 2 question, which I finished grading. So look at my answer key there, and I will talk about the lab manual answer keys. Make sure that you really grasp the idea of finding the function domain and range from the graph, if a function is 1-to-1 or not, by using what technique, you know the name, I'm not going to say it, and write it in a complete sentence, and so on and so forth. So the other question is about end behavior. Again, you might be asked, find the domain, find the range, what's happening to function, as x goes to negative infinity to positive infinity. Are there any vertical asymptotes, horizontal asymptotes? What are they? Remember that asymptotes, horizontal or vertical, are equations. So if it's a horizontal asymptote, it should be y equals line. If it's a vertical asymptote, it should be x equals line. All right? So they're not points. So be careful on that also. So it's a similar question on number 4. Again, similar question on number 5. Number 6 is a good question about the context of average rate of change. So we can find the average rate of change in 2 other ways, like delta y over delta x, change in y over change in x. Be careful, comply with the order. If you're putting y2 over y1 divided by x2 over minus x1, it should be. If you prefer to choose y1 minus y2, then your denominator should be x1 minus x2. And there are other ways to find the average rate of change by plugging in the function values, which is coming, I guess, in the future question. But also remember to interpret the meaning of average rate of change. What does that mean? As x increases, y increases with a rate of change. So it's written on the PowerPoints. I can't go every detail of it. I'm sorry. Trying to give you a snapshot, some focus points. So absolute extremas, absolute min, local min, absolute max, local max. You should be able to provide them from the graphs, naming them correctly. Increasing, decreasing, increase, decrease, and increasing, decreasing intervals are given with the x values, input values. I know that if it's increasing, you want to go till the top, and also this point, for instance, we're increasing here from negative 3.16 till 0. Negative 3.16 and 0 is not included. The point that you start for increase and the point that end in either direction is not included, because those points is actually absolute min or absolute max. Function is not increasing or decreasing at that point. So be careful about that. Look at the answer key again here. Finding the domain and range of an inverse function from the original function. You can first identify here what's the function domain and range. And the function range will be the inverse function domain, and function domain will be the inverse function range. Finding the combinations of functions, just addition, subtraction, and multiplication. Luckily, we don't have division. Division is coming. So the domain of the combination of the functions should be coming the intersection of f and g. This is on our last week. Remember that these are quite easy compared to other ones. So finding a solution of systems by reading it from the graph, their intersection points, right? It's just a quick subject, transformations of functions. So you do the transformations in terms of actions in what order, and what are some of the points that you're picking up from the graph, what algebraic operations you're applying for them, and what outputs or input changes is happening, and what will be the new function. So this was your group question. Again, I still did not and could not grade it because not all the group evaluations complete. Please do so. I will talk about it also in the announcement. This is a similar question 13, like the beginning one. Average rate of change. Find the average rate of change within the interval. It means that you need to, for instance, calculate f of negative 2, obtain a y value, calculate f of 1, obtain a y value. So you have two values, take the difference, divided with the differences in x values. You're going to compute the combinations of functions again. Not going to spend more time on it. How would you add the functions? How would you subtract the functions? And how would you multiply the functions? All right. Don't go crazy when you're adding them. For instance, in part 2i, if you're adding them, there's no combining like terms there. It will be x squared, square root of x minus 5, and plus 3. That's it. No more. So don't try to do like multiplying it with the complex conjugate with your previous knowledge, rationalizing the denominator. No. Just look at it. Can you add them? Are there any like terms? Yes, there are. Then do that. No, there are not. There are not any like terms. Don't do it. Just leave it. All right. So this question 60 is about domain of a function from the equation. So remember, domain restricted if a function is a rational function, if we have an x value, input value in the denominator, if there's an even root function, or logarithms. We didn't see the logarithms in here, though. So the only restrictions that you should be dealing with for this module, hence for this module, there's a restriction in the logarithms, but we didn't do that in module 1. If a function has an x value on denominator, then denominator cannot be equal to 0. If a function is even root function, even, not odd, not cube root, not fifth, not seventh root, then the inside term should be greater than equal to 0. Okay, so make sure that you really understand this question 16, all the parts well. Answer key is posted. And solving absolute value equations, right? You're going to have probably a problem like this. So do you really need to show all your work? Let's talk about it just a bit. For instance, function like that, you're just going to write down an answer, what kind of work you're going to show. Or here in question 2, there is no work. So this key is actually served as a solution also. Solution means that you have some work. Key means that you just have the values. But sometimes values will be merely the solution, could be also. So that's the case. So that's the same here. But for instance, this average rate of change problem, you really need to show the work. This is just key, number 6. I really need to solution. I really need to see your work in regards to that. I don't think that I will need to see any work here for this increasing, decreasing, absolute, min, max problem. Same here, domain and range. I would say same thing there. However, transformation functions, you really need to give the table of values. What happened to those points to choose? What actions did you do on this graph? Then you obtain negative fx plus 2, right? It requires a little bit more work. Same for 14, that will require work. Question 16, you really need to let me know, how did you get this answer? Why is it like that? I really need to see some of the work, bare minimum, or solving equations. You're solving an equation, right? How did you get those x values? I really need to see them. So I write some things in the announcements also. Please read them. Remember that all 4 WebAssign quizzes are due tomorrow morning by 7:59 a.m. The other thing is that I really need to mention is about group evaluations. So you really need to post your feedback to group evaluations. Otherwise, your group will not be, I won't be able to grade your group work. Whatever it is, however you feel, it's confidential, it's only for my eyes. But if all group members are giving you a feedback that you did not contribute at all and you were radio silent, I'm sorry. Maybe that was your busy week, or maybe some other important things were happening, but you will not be honored for the grade and you will be counted as absent. And remember, you can only have 4 absences. After the 4th one, I will need to withdraw you from the class. All right, that's all I want to say. It's already 14 minutes of video. So happy watching. I hope it was helpful. Let me know if you have questions and concerns. I'll do my best to get back to you as soon as I can. Happy rest of the Sunday. Bye. Best of luck in test 1 also.